Hello, everyone, and welcome. Thank you all for joining us for today's session. My name is Firas, and I'm the event planner for Microsoft Reactor in Redmond. Before we start, there are a few things I like to go over. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our presenter and audience. We encourage engagement in the chat, but please be mindful of your commentary and please remain professional and on topic. This session is recorded. It will be available through the Microsoft Reactor YouTube channel in 24 to 48 hours. I'll be sharing the link to the YouTube channel in the chat. I'll also be sharing the link to the survey if you want to let us know how this event went. I'll also be sharing the link to our Meetup uh, group so that you can see if you want to go and check more sessions. Which brings us to our session today. This session will run approximately for an hour or a bit more of an hour with time for questions within. Our speaker for today is Armando Lacerda. He's an Azure Data Platform Architect and Engineer. I'm going to hand this over to you now, Armando.
Thank you very much for us. Good morning, everybody. If you are watching this session live, it's morning there in the West Coast. I live down there in California, but this week I'll be here in Florida. And if you are watching online, good morning, good evening. I mean, if you are watching the recording of this, good morning, good evening, good afternoon to everybody. Our session today is on Python, right? Let me bring here our session. There you go. Our session is on Python and how to, how to get started with Python, how to do your first code and start having fun with this language. As far as introduced me, my name is Armando Lacerda. I am besides being an independent consultant and a cloud architect, data engineer, I'm also a Microsoft MVP. This little blue icon here, it's the Microsoft MVP award logo, which means that I love to do what I'm doing here now with sharing what I know with the broader community, and I hope you can benefit from this. I'm also a Microsoft trainer, certified trainer. I've been teaching Microsoft classes for over 26 years, and it's been fun. I love being in the classroom. I was teaching a class earlier today, and I hold multiple Microsoft certifications. This is just a few of the Microsoft certifications logos that are in there. If you want to get in contact with me, I'm more than happy to connect with you through LinkedIn. It's my preferred social network to get professionally connected. My Twitter handle is kind of an echo of what happens on LinkedIn. And Facebook's more of a personal thing. Like I said, I'm here in Florida. My family's on vacation. I'm working, but we had a good time yesterday. So if you're going to see me wandering around Florida, you'll see there. But the topic of the moment is actually Python, right? We want to learn about Python. What does this think about Python? So let me get my mouse over here. There we go. So what is it about Python? What's going to be our agenda for this session, for this next hour or so? First is, why learn a new language? Why should I learn a new language? If you're here, there's a good chance you have done coding before. There's a good chance you have developed something before. This is a one-on-one class, so there is also a chance you have never done any code. But in case you have done some code, I'm going to share with you some of the reasons that I myself got into Python. I am a data architect and a data engineer today on my current job description. But I started as a developer way back. I'm going to tell you my story in a few. And I consider myself a developer in recovery, but recovering developer. But why learn Python, right? Why get to learn a new language if I already know one or two, or in my case so many? So we're gonna go over that. Then we're gonna see how to set up our environment to start doing Python code. So we're gonna see the details and the dependencies that are around Python. And then we go for code, right? I don't have that many slides in here, just to share some ideas, and we're gonna go straight into coding. We're going to do a first code, and we're going to build up on the code we have created and get things going. As you may know, this particular section belongs to a series of sessions called Build Up. And the idea of this Build Up sessions is to invite you, is to motivate you, to actually get you to browse a Microsoft Learn website. Microsoft is investing a lot on getting people resources to people so they can learn Microsoft platform, Microsoft resources, and a lot of those learning resources, they are made available for you for free. They are available to you for free, and it's on Microsoft Learn website. I'm gonna get to the website when you get to the coding session, portion of this session, and we're gonna have fun in that. So all the demos are gonna run in here. You will have the chance to run these demos on your own. You will be able to go there into the Microsoft Learn and see the steps and do it on your own. So I highly suggest to you, as soon as you finish here, have a chance, jump on your computer and start coding, right? Following the steps there in the Microsoft Learn website. So let's go for it. Why learn Python? So these pictures here, I got them out of a museum. I really did. I actually took, I live there in California, like I said, in Silicon Valley, the south side of the San Francisco Bay Area. There is a computer museum there. And I took my daughters there with me once, and I showed them what I'm showing you. Say, look, this is where that started over 30 years ago. The very first computer that I ever wrote code for was this guy here. I'm from Brazil. I came from Brazil here back about 20 years ago. But when I first started there, this was the TK85. It's a Z80 processor. It's a copy, kind of a clone of this guy here, a Sinclair computer that runs on the same chip, the same CPU. And I was a little teenager back then, and I was walking around some store in there, and someone got me, gave me this piece of paper, say, look, sitting here, you see this keyboard, type this, put your name there, and hit run, and see what happens. And I did that, and then my name was on TV. Say, oh man, look at that, my name on the TV. My mom is not going to believe that. So I rushed home, I told the story to my mom. My family got me one of those. This is how they look like when they are set. This just the keyboard, the computer. So here it is, the power supply. And there was no floppies or flash drives or anything on the cloud. It was just K7 tapes where you record your data and it hooks up to a TV. It's fun to look at these things. But here's the point. When I start learning this guy, I start learning a programming language. And in this case, it was the BASIC language. It was an acronym. BASIC stands for basic, although it's an English word, stands for an acronym. And beginners, all-purpose, symbolic instruction code, something like that. And then I learned how to program in here, right? I learned a computer language called BASIC, and I was able to program for this guy and for this guy. And life was good. I was really happy. Once I finished my first technical class back then, and then I got a job, as an internship job in some companies there in my hometown, I was introduced to this computer here. Actually, it was this one down here. Where's my mouse? Mouse disappeared. It may not come back. Okay, there you come. Maybe there we go. I was introduced to this computer here. This was again a Brazilian copy of the TRS Model 3. And the person who hired me there said, yeah, we have this computer here. It's a more robust computer compared to the other one, the previous one. And this one also, you program in BASIC language for this guy here. Say, yeah, I know BASIC. I can program in BASIC for this one. And when I got to program for this guy here, I very quickly learned that the BASIC language for that computer is different from the first one, from the Sinclair one. So the TRS Model 3 running the BASIC language, the language itself was slightly different. There was some specific constructs to it. So I have to kind of relearn a little of the language. I had some heads up, but I had to relearn the language. And then someone introduced me to the Apple computer. And this is a picture of the Apple II with the floppy drives there already. So a picture of the Apple II. And Apple II, guess what? It's BASIC. So yeah, I know how to learn. I know how to program in BASIC. I know two types of BASIC language. And when I got into the Apple computer, it was a third version of the BASIC language. So in a period of about 2 years, I have to learn BASIC 3 times in order to learn how to program for distinct computers, distinct environments. And here's the point of it. In order to get the computer to do something for you, you have to give computers instructions to do whatever you want the computer to do. And that structures your code. It's in the code will be some programming language. And in this case here, if you learn a programming language that can be used in multiple places, it will help you. You don't have to relearn the language every time. Actually, it happened to me not just on these 3 computers, but in my career. This is pretty much the summary of what actually happened. So I learned the one for the Sinclair computer, for the TK, and then for the TS Model 2, the TRS Model 2, and then the Apple II. Then I got a job on work with mainframe, so I had to learn COBOL and RPG. And I had the time working with DEC. It's a company that doesn't exist anymore. IBM is still around, but DEC doesn't exist anymore. And for DEC, I have to learn Fortran. I tried to run away from ADA, but I got to get a little bit of it. And there was another 4th version of BASIC in there too. So in the beginning of my career, I had to learn like 10 languages because these languages, they were specific for the environment they were designed for. And that's the beauty of Python. When these guys, they started creating Python, they developed Python about 20 years ago, they had this idea of we need something that's multi-platform. We need to get developers to get up to speed and be more productive as fast as possible. And one of the ways of doing that is by shortening or getting to 0 the learning curve to program to a particular context when you have to program for context. So the key factors to choose a programming language, they go around these 3 main points. One is the supported platforms. Where will my code run, right? If I write code, will my code run on a PC? Will my code run on an iPad? Got an iPad here. Will my code run on an iPad? Will my code run on a cell phone, on a Android? Where will my code run? If I have to write the same application to another platform, do I have to rewrite from scratch from another language? So what are the supported platforms? The second one, what are the available libraries? We're going to have the first code we're going to do, we're going to use some libraries in here, and libraries are something that's very, very important because they shorten the time for you to get something done, created, and allows you to focus on the problem at hand, not on the infrastructure elements. Like if I want to present a message on a screen, I don't want to learn how a particular OS like the Android or iOS or Windows or Linux, how do I connect to that one? I just want to present that there. I want to send a message to the screen. And the ins and outs, the internals of these things, the libraries are supposed to do that for me. So when I choose a programming language for my professional career, I should choose one that has libraries that are, have enough breadth and depth to cover every aspect of the field that I want to, automate with my code. So libraries are super important. And another thing that's very, very important is the popularity. I mean, is that an adoption? Is that a language that there are more people besides me interested in learning and using? I mean, what's the most, if a language is not spoken, it tends to die. I don't know if you have heard about Esperanto. Esperanto is a language. Last time I heard there were just two sisters. They actually knew how to talk Esperanto. I have Duolingo on my cell phone in order for me to practice my English. And Esperanto is there, but I'm not sure how many people are learning Esperanto there. But from Duolingo. But the point is, when you choose a language, you should choose a language there where you're gonna find a community that will help you out, and you can also contribute to that community to help people get things done on that particular language. And Python checks all three markers. It's just the perfect environment. And the funny thing is, you are here on an event sponsored by Microsoft. It's actually organized by Microsoft through the Microsoft channel called Reactor. They have physical places in multiple cities, and they have these online channels. We have been meeting here lately, mostly because of the pandemic, but they start opening up. So we are here on a Microsoft context, in a Microsoft environment, learning about a language that is not Microsoft's. Python was not developed by Microsoft. Python belongs to the open source community, and that's the big thing about Python. It doesn't belong to a vendor like the ones I mentioned to you before. All of them belong to a particular vendor. Those ones from DAC, unless if you're bumping into a DAC server someplace, you're never gonna see those languages again. It's just trash in my head now. But with Python, you see, Python has this very strong support from a community that contributes to the codes, to the source code voluntarily. Most companies like Microsoft, they are interested in giving to the Python library new code, add new tricks to the library, so the people who know Python, they can learn, they can do things on Microsoft technology. So that's why we're here, because of the popularity and because of the libraries that Microsoft has made available to the Microsoft products itself. Microsoft products themselves, I'm rather say. For instance, when you go to the clouds, when you start doing cloud computing, there is a thing in Microsoft Cloud called the CLI, the Command Language Interface. And that's how most people like to work in automating things in the cloud. They create scripts in CLI or Terraform or someplace else. The funny thing is, the environment that allows IT administrators to work with the cloud was fully implemented in Python, so it can run in multiple platforms. So Microsoft invests heavily on the Python platform, and that's why you should, it's a good choice to learn Python, because it works in multiple places, in multiple contexts. Just to give you a broader idea of that, this Python language is so pervasive, it gets to so many places, that if you are going to work with big data, like I said, I'm a big data guy, right? I work with data architect and data engineering. Oh, I see a question coming up in there. Is there a chance Microsoft will replace VBA in the back end of Excel with Python? I have no idea, AB. I have no idea, AB. More likely, not replace. Perhaps Python can pop up in there. Actually, never checked if there is a Python library for Excel. There are some Excel tasks you can do, but I don't think there is a specific library for Excel. I have to check. I really don't know. But Excel has its own context, and it's a good question. Excel has its own context, and people who work with Excel, they've usually been working for a very long time, so there is a very solid library in VBA for Excel. So if you ask me, in my guts, I don't see VBA going away from Excel. Python could be added at some point. I don't see that happening. Never heard of that, but it could be there. Who knows? I don't. But yeah, so in my case, I'm a data architect and a data engineer. So I do a lot of data transformations, data processing up in the clouds. And if you are going to use a cloud scale resource to do data crunching, like Spark and all the products that derived from Spark, like Databricks and Azure Synapse, Python is supported in there. So if I want to program data transformations for the Spark cluster, I can learn Python and I can use my knowledge there. Now, if I get transferred to another project and then I have to create websites, web applications to to deal with communication over the web, either a graphical user interface, a web application, or just back-end processing using the network. Guess what? The same language, no change, exactly the same constructs. Everything is the same. Just the libraries will be different because the libraries for Python is one. The libraries for a web application will be another. There's a question that does Python work well in Azure DevOps environment? 100% agile, 100%. So another one, Nelson, how feasible is Python when compared with PowerShell? Well, that's a good question. So PowerShell is very specific, very narrow for IT administrators. So if you are in the Windows platform, you came from command line into PowerShell, and then you do your scripts in PowerShell. But nowadays, PowerShell is more portable than it was a couple of years ago. So you can use PowerShell in Linux to do some tasks in Linux. But the libraries of PowerShell and the environments of PowerShell work, they're very limited in comparison to Python. So like I cannot use PowerShell to do a website, a web application, or data transformation, but I can do PowerShell for IT administration and automating tasks. Python can be used for all three cases. So you see, PowerShell is very narrow when compared to Python because Python can be used the exact same language multiple places. CLI, I just mentioned CLI. CLI is developed in Python itself. The libraries that talk with the REST API in Azure are developed in Python, and the client side of it is developed in Python. If I want to do data science, Python is huge in data science. That's such a large library for data scientists. And if I do machine learning, same thing. So notice 1, 2, 3, 4, 5 disparate contexts, and the language is the same. What are you gonna the few elements you're gonna learn here in this session will work exactly the same way for all environments. By the way, Microsoft, one of the most popular languages with Microsoft is C#. It used to be VB, Visual Basic, because Basic was such a big language in the past. So Visual Basic used to be the most popular language for Microsoft. I think C# took over. VB is still around, and VBA is Visual Basic for Applications, which is script. It's very confined to some niches like office automation on the desktop side. So C#, Microsoft has worked to get both the .NET platform and C# kind of the same technological level of Python. So the same way Python is portable, Microsoft is pushing hard to get .NET framework and the C# language as portable as Python. But again, C# is open source. Microsoft made it open source nowadays, like Python is. But Python's ahead of the game like 15 years in terms of being open source. So again, it has way more popularity than C#. I myself, I do okay on both. I love C#. I've been programming C# since it was released in 1999. But Python is a great language, and now it's time to get into Python. So I hope that motivated you to set some time to learn Python, to get deep into Python. I'm going to show you some activities here from the Microsoft Learn library, the Microsoft Learn learning paths on how to do stuff in there. In this case, it's going to be Python. And let's go have fun with the codes. But again, it's not going to be a waste of time. Just one last story. My daughter, last year, she was in high school, and she was like, "Daddy, I want to learn, how to do coding, how to do programming." And I got her into Python. She got into so easy into the thing that she was doing a small piece of codes to do her math calculations for high school, for her senior high school year in the computer. And she was so excited about the thing. And she's now moved to something else, but she had a good time. And the language she learned was Python and was that quick using the same resources I'm going to show you guys here. So let's go ahead and let me switch here from this set to this set here. And let's get into our coding environment. And I think this is my guy. Yep. I just need to get this full screen. There we go. Perfect. Let me minimize code. I'll be back in code in a second. And I'll be back to this guy here in a second too. Yeah. So this is the website. Well, Microsoft, if you have been here in other sessions on this build skills, you know that aka.ms/learn gets you to the Microsoft website for all learning paths that exist for Microsoft. I'm gonna get this a little bigger here so you guys can follow along. So this is aka.ms/learn gets you here. The full URL is that one over there, Microsoft Docs or Microsoft.com/learn. And here there are multiple learning paths to multiple technologies, both from Microsoft and also open source. And some Microsoft partners like Databricks is in here too. Databricks, they have their own learning path, and you can go to Databricks to learn this stuff. But there is some entry-level content in here as well, made for free, and of good quality, I should say. In our particular case, my friend for us should put there for you on the chat window the link for this particular learning path in here, which is this guy. Where is it? My mouse here, which is this guy here, beginner-Python. Right, you should get that one in there momentarily. And just grab this guy here and copy. Let me see if I can get that over here. There we go. Here and here is for us, doesn't have the link. I just put the link there for him so he can share with you. All right, so how does this work? These learning paths, they have a collection of sections. You see, this is the first section, this is the second section. And in these sections, they have the topics where they're going to introduce you to some subject. And usually they have these exercises. Sometimes these exercises, Microsoft has built a sandbox for you. So you just have to click and a window will pop up for you to try out code, which is super fun, write code or whatever you're learning about. Like if it's an Azure technology, an Azure subscription, the sandbox will pop up there for you, so you can do your things without spending money on that. And sometimes you have to have your own computer. Microsoft on the learning path to decide it's better for you to create your environment to start doing things on your own computer. In this particular case, for this one, the first section here is about running things from our own computer. And so let's get started on it. If you sign in, you will count points. You see, there is some this whole section here counts 10,000 points. So you can kind of a gaming thing, you can accrue these points. And as you finish sections, you get badges. That's not like a certification, not definitely a certification, but shows that you have spent time and try the exercise and you have spent time doing some investigation on this. So let's go ahead and try this out. The first one here is going to be this guy, right? Get started with the environment and Jupyter Notebooks. So I'm going to control click in here just to get started. You will have this text in here that you can take your time and read it on your own later, right? And they kind of sometimes they introduce you the context of what you're coding about. Sometimes it's the actual lesson on the language, in our case in Python. In this case here, they're like, hey, we're going to do some Node.js. We're going to do, actually, no, we're not going to do Node.js. Node.js is an option as a programming language. Java is another one. We're going to be doing Python here. And what we're going to be doing is like, they chose a fun subject. It's like you're a crew member of the International Space Station, and you're going to develop some code to pop up some messages, pop up, make something happen, like start the engine of some module or something like that. So, that's just the background, the context of the code we'll be doing. And then we're going to go into the code. So first thing, in order for this to work, you have to set up your environment. What does that mean? You have to download some software to your computer. And because, remember, Python is multi-platform, right? So if you run a Mac, if you run a Windows, if you run Linux, whatever environment you are running, it will be exactly the same thing, right? You will have to download some pieces of software. One of them is definitely Python, and the framework, the SDK for Python. And the way you do that in Python, depending on the environment, you have some specific way for the environment. The most generic way is like if you Google the thing and do download Python. You go, first hit in there is the download Python web page, and you can just click from this button here. And if you don't have Python already, you're gonna get the latest version of Python. Talking about version, although it's the same language everywhere, like I mentioned before, Python is still a versioned software, which means that if someone created code for Python 2, if you try to run that code in Python 3, it may not work. More likely will not work because there are differences in libraries and things like that. The language is the same, but there are differences in libraries and environments, so it may not work. If someone created a code for Python 3.1 and now you are in Python 3.10, there can be things that will not work, because usually when there is a change on this second number, there are some breaking changes from version to version. So always look into, when you see some code, which version of Python this code was written for, right? And always have the correct Python environment for that particular code version. So it's a thing, right? Still, I mean, it sounds like Python runs everywhere. It does. Sounds like this. The language is the same everywhere. It is, but there are minutiae there are not. So be careful about the version. Yes, so you download it. I have already downloaded, and I know that I have it in here because if I go to my command prompt here in my Windows 11 virtual machine up in the cloud, I have here the terminal, and if I do this, yeah, look at that, it responds. This is the size. So I hope this size is big enough for you guys to follow. If it's not, let us know through the chat window. So if I do here Python -- version, it tells me I'm running Python 3.10.5. See, it's already there. If Python was not here, I would get an error message like this. It's not there. I don't recognize this thing, right? I just added an X there at the beginning of the command. So I know Python's already installed. I have already, for the sake of time, I have already done that. So the first thing you will need is having the Python environment. There's some question popping up in here. Let me see. It popped up super fast. So let me check it again. Does this course cover the SCAPPY framework? Nope, it will not cover any particular framework. It's the first step on the language, not any particular framework. Sorry about that, Agile Coach Carter. Agile Coach Carter. I like the movie. I like the character. The guy's super, bright guy. I like him. All right, so yes, so Python is already there. The second thing you will need, I go back here to the browser. The second thing you need is an environment to write your code. In this case here, Microsoft will suggest it's on Scrappy framework. Yeah, no, we're not going to go into the Scrappy framework, Coach Carter. So Microsoft will suggest here the Visual Studio Code. You can use any editor, right? You can use, if you're in Linux, you can use a VI if you like, but you can use any code, but any code editor. But in this case here, we're going to make two choices. They're very strategic. One is Visual Studio Code because it's Microsoft and it's portable. It runs in every environment where Python is, almost all, at least Windows and Mac and Linux. And we also going to use this particular style of coding, which is using Jupyter Notebooks. So Jupyter Notebooks is something that came super popular. You're going to see why. Because usually codes like this long sequence of commands, one after the other, and it is just a long sequence. They call it a script code, very long sequence. With Jupyter Notebooks, you can better organize your code and be selective about which portions of your code you want to try out, you want to execute, you want to refresh the memory. So these two guys are super fun. Visual Studio Code, you download it the same way, right? Like this one here, it's the way I downloaded, I would download Python. So if I go here, download VS Code, Visual Studio Code, I get a link for it, download Visual Studio Code for either environment. My one is already installed in here, so Visual Studio Code is already here. This is my Visual Studio Code. And when I get into Visual Studio Code, let me get the size of this a little bigger so you guys can follow along better. When you get into Visual Studio Code, here on the left side, you have these blades. And right after installation, it usually ends in here. You may go here into testing. I'm not sure if testing is there out of the box. But this blade here, we have less buttons than what I have in here. Because one of the things in Visual Studio Code is you can add extensions. This is a very interesting thing. You can add new functionalities to the code editor, to Visual Studio Code. Some people come in here to program in C#, they don't care about Python, so they don't want Visual Studio Code to know about Python. Some people like us come here and we want to learn, we want to program in Python, but we don't care about C#, so we don't have to add things to Visual Studio Code we're not going to use. So here on the extensions, you load things into Visual Studio that will help you on doing your coding. So what they ask you to do there is after you have installed Python and after you have installed Visual Studio Code, of course, you're going to install the extension to help you out with the Python language. And in my case here, you see the one I have in here is already installed. I have a button here to uninstall it if that was the case, which is not. So it's already installed. And very important, you see this one here is authored by Microsoft. You see the name over here, authored by Microsoft. These extensions in Visual Studio Code is open source, like Python is too. And there are other people who create extensions for Visual Studio Code besides Microsoft, of course. And most of them are great, but everything here is open source, which means you may get some ones that are not stable, and you may want to contribute to the project yourself. So make sure that you know the author, right, the source of the extension, and look into the documentation, read the documentation page to see if the extension is stable enough. And there are people using this and contributing to the maturity of that extension. In our case here, we're going to use both, all the sources from Microsoft. This is one of them. Oh, look at that. This one here has been retired. See, Python language extension for Visual Studio Code. This extension is deprecated and no longer maintained, and no longer being maintained. Meaning I should not use this guy, and I'm not. The other extension is for the Jupyter Notebook, and it spells with a Y, Jupyter. Also from Microsoft. So here's the Jupyter Notebook, and there will be an install button here. If you don't have it, actually gonna uninstall and install it again just for you to see. See, when you don't have it, there is this install button, and you click on the install button. It says installing. Sometimes it requires to recycle Visual Studio Code. In this case, it didn't, which is fine. You see, remember the popularity. You should choose something that everybody, and there's a big community around it, so people know what's going on behind the scenes in there. This one here was downloaded almost 40 million times. It's kind of popular, right? I think it's a good idea to take a look at this. So there we go. This is the environment we need. And yeah, let me close this tab here. And let's start doing code. Let's go back to the, what is the thing? Let's go back to, oh man, I have to click here. Yes. Let's close this guy, yeah, back in here. So I have this prerequisites, right? All these elements already there. Time to do some coding. So this, remember this session, this learning path in the Microsoft Learning Center, right? This path is start from the beginning, but just to have some fun, just to check the environment, if the environment is working for you, they start here with some kind of advanced code. You know, they go into something that's working first, and then they start from the beginning to explain the bits and pieces, you know, all the elements involved. So the first thing that shows up in here is like, you're gonna go to Visual Studio Code, you're gonna create a Jupyter Notebook, and the way to create a Jupyter Notebook is by giving this command here to Visual Studio Code. I'm gonna show you how to do that momentarily. And then you're going to get this code, this code here into there. So don't be like you know, intimidated by this code. So oh, look at that, there's a bunch of code in there already. I don't know half of it. I don't know the first of it. It will go easier after that. This is just to test if everything is working, right? So let's see. First thing to do is creating the Jupyter Notebook. So let's go back to Visual Studio Code. Let's go back to Code. And in Code, on your keyboard, you have the F1 key. When you press the F1 key, you get this command palette in Visual Studio Code. All the extensions, they all have specific commands you can do from here. Code itself has its own. You can see some Azure commands here as well to do things in Azure from here. So one of the things that developers do, because they're always typing code, is like, instead of going to the menu, use the mouse to click around, I can just type straight from here. And that's exactly what we suggest you should do. If you go here, Jupyter, see, you see the commands for Jupyter right there. So you can do this, debug cell, filter kernels. You have a bunch of elements in here. And of course, one of the things you can do is to create a Jupyter Notebook. And that's exactly what we want to do. So we're going to hit enter on this guy here to create a Jupyter Notebook. And here's my Jupyter Notebook. And at this moment, it doesn't have a name. So I'm going to save this guy. And I'm going to save here. I have a folder on my computer up in the cloud called Lab Reactor, where I save my things. And here on the steps, they kind of suggest a name. You don't have to use it, right? But I'm just going to use it just for fun. The structures that are in here is like, you create this notebook by first creating an empty file from the command prompt and then calling it from code. So we can do either way. I'm just this way here just because I found it easier. So let's name it as it should be. There we go. Ship manual. Let's manually control our International Space Station. In Visual Studio Code, because we are using the Jupyter Notebook, what we see here are these cells. And the thing about these cells is you can have multiple cells. So we're going to add more cells in here, see? And these cells, they can have code, like you can see here, or they can have comments, remarks, like kind of documentation. So if I click on mark down here, let's go ahead. There, I had a choice. Let me erase one of them. So if I click on mark down here, whatever I type in here, it is just remarks. Or comments. Whatever I want to give you here, like a clue about what I'm going to do or what I have just done. And Markdown is kind of a language that you can use. It's not similar to HTML, but it has some HTML features to it. If I want to put this thing here in bold typeface, I can use some of its acronyms in there. When I click off of that, it should, but it didn't. Oops, clicked wrong again. It would show that as a as a styled element. So the bottom line is the Jupyter Notebook has these cells, and these cells they can have comments and they can have code. And when they have code, the code can be on each cell can be of a particular language. Like I have Python in here, but I could choose to have codes in HTML, in JavaScript, anything that's supported on my programming environment. So Python is the Python Markdown, the two ones in there for the Jupyter Notebook, but I could have like even PowerShell that was just asked about a moment ago, right? And you can add more languages in here if you like. Great. And in order to execute code in a cell, you first have to have the code. So let me go back there to the browser. And here they are like, yeah, so you got the notebook in there. Make sure that you have your notebook connected to the Python runtime environment. So if I go back here to Visual Studio, I will see here on the top right corner that Visual Studio has already detected. Remember, we downloaded the extension, so Visual Studio already detected this Python installed on my computer, and it's version 3.10 and it's running 64 bits. If I click in here, and if I had more versions, I could choose other versions. Remember, if you have a piece of code for a particular version, it should run on that particular version. And you can have Python installed side by side, multiple versions. Sometimes it gets confusing, but it is supported. So make sure you have a runtime environment connected in here for Python, and then you can have your code and execute your code. So let's take a look in here on the code, back in here. Here's my code. Oh, here's my code. Let's get the code on this guy, copy code. And let's get the code into the cell. So I don't need this cell here. I'm gonna erase this cell, trash it. I don't need this cell here either. Let's trash this one. Here's my cell. I'm gonna put my code here in the cell. So this is Python code, right? What we're looking at in here is actually Python code, the sample code they have there in the site. Now notice that Python is already complaining here, right? It's like there's this word in here, IPY widgets, that I have no idea what this is. This could not, you see written over there, could not be resolved. Let me do something here, just quick. Let me see if I can do something here. Give me 1 second while I click here on the other screen. Let me see if this works. It does. Look at that. So let me hover over here. You see that little error message here that says could not be resolved. It means Python is like, I know this is code in my language, in Python, but this particular name here, I don't know what it is. And if I try to execute this code by clicking on the play button for this particular cell, just the cell, if I click on this guy here, and my mouse disappeared, here's the mouse back. If I click on this guy here, it's trying to, oh well, it did execute because I have already done the other one. But if you try it right away, it would fail for you. Why would it fail for you and did not fail for me? Because from the instructions here, the guys are like, we want to have these visual elements on the screen, like there is a button here on the screen, and anything besides the actual language that you need happening for you, you need a library. You have to download a library. It happens that I have already downloaded. I was testing the environment before this session, so I was already testing it, and I already downloaded the library. But if you try it right off the bat like this, it will not work. That's why here on the instructions, before they ask you to put the code, they ask you to run this command from the terminal window. This command here, Python package installation, Python installation package. It's a command line tool to install libraries when you need to do a library, when you need to execute a library. Like if I'm doing data science, I would do pip install and the library name that I need to do my data science thing, right? The library name, whatever it is, scikit, whatever it is. In this case here, it's just elements to draw things on a screen. So in order to do this, back in Visual Studio Code, what you do, you ask for a terminal window. And again, if you press Shift F1, you can do here terminal. So you can have terminal clear. I have open this one here, open new terminal, external terminal. All of these ones here would open a terminal for you. Another way to open a terminal, there are some shortcut keys that I invite you to take a look at and research later. Control tick, the one right under the escape key, opens a terminal there for you right there. So, there are multiple developers like us. We love to use the keyboard. We avoid to get into the mouse or the trackball because our hands are already here, right? So all shortcuts on the keyboard, they're always welcome. So pip install, what's the library name again? Let's take a look in there. My mouse here. So let's take a look. Come on. There we go. So IPY widgets. Let's get back there. Come back. There we go. So if I do this, in my case here, it just shows me that everything has been already installed, and it just gets the thing. Hey, you're ready, man. What are you asking about? When you do this first time on your computer, you see there will be some progress bar going on. Download things from the package library up in the cloud. You have to be connected for that because you're gonna download from the cloud. And then I don't need that anymore. Control ticker there, takes the terminal away. So this code here, what this code does, it uses that library we have just downloaded. That seems like this I cannot see, but it's there. And it gets a button. See over here, it gets a button. Hey, I want to have a button, and this button I want it to be have a label called Start Engine, and the button style is going to be success, which is usually kind of the color thing, the green color. It worked. Where is my clicker here? There you go. Success. If the mouse hovers over that button, I want to show that message here. It's called the tooltip. And I want to have an icon associated to that button. It's kind of a rocket. So this is the description of the button that I want to have. And this button, it's something that the library already has. I'm just getting the library. See, widgets, it's coming from the library. We just imported and putting into this name here. This label is actually a variable that becomes an object. We're going to see more details as we move along. Down here, I get this library, right? And we have this output object from the library, which is when you want to show something, it's got to show someplace. And the generic place to show something is this output place in here. So it's not a new window that's going to pop up. It's going to pop up whatever is the standard output for the running context. Display comes from the library. Actually, let's see here. Yeah, so display comes out of the library, and it, yes, I think it is, yes. Comes out of the library and gets two objects to it. It gets to the output where I want to write it, and ignition, which is my button. So it's getting the two elements in there. And it's associating actions to that button. So if people click on that button, when they click on that button, see ignition, my button, observe. And if someone clicks on that button, something happens in there, I want you to check. If the button has never been clicked before, show started. Otherwise, show stopped. So if I go here into the button, see the rocket icon there and the green as the success. So if I click here on the start engine, because it has never been clicked before, I get the engine started. Now it has been clicked already. So the next test in here is it changed true? Is change new there? Is it true? In this case, when I click, it's already there. So the engine starts. So this code here is just doing this, right? Is defining the button. Look at this guy. Defining the button and adding the button to show up on a standard output, and listening to the events of the button. If someone clicks on that one, if the button was just created, put started. If it was already started, click stopped, and it keeps changing, right, between true or false as needed. So noticing here that the name for the value going on in there. So there we go. This means that my code is ready, my environment is ready. I'm good to go to get started learning Python. So I know it was a heavy code to get started with, but the goal here was just to have fun, to see that the engines have started. We are ready to learn Python. So the next step is drink some water and start getting the language from the beginning. So let's go on in here. That's the expected result. We have just seen that. Moving on. And then is the next exercise. So in this next exercise here, they will start creating some visualizations. Now this one starts from the very beginning. So let's take a look at some of this code in here. I'm gonna copy this code for the sake of time, and I'm gonna paste it into a new cell, into my Jupyter Notebook. So I'm gonna get here new code cell, and I'm gonna get, or actually I could have a markdown in here and say this is the second exercise. Second exercise. And here I get my code in here. There we go. I think I see a question coming up. My screen is a little blurred. I guess as big as possible. It's probably your network bandwidth, Franca. Perhaps you want to check out later through YouTube because it will be more stable there. If you're interested in finding out, okay, that's for us there, perfect for us. Now dug in here, how would you change the text in the button from start to stop each time it's toggled? Oh, it's already there, right? It's already doing it. So it's looking into the output. See, I get the ignition and get a second parameter here, which is the output that's being sent. So if this output guy here with output, if this guy is new, is not being there, you set it to true, you get it to start. If it's already there, you send it to stop. It's just a simple logic, right? Boolean logic, one state or the other. So that's how it does it over there. All right, let's take a look at this second code here. So this second code is kind of fun because it really starts from the beginning. What are the basic elements of the Python language we see here? The first one is getting the libraries you need to do your work. Because if you don't have any libraries, you have to code everything yourself. So when you want to do, math, when you want to print things on the screen, when you want to, change data coming from a data pipeline, you have to learn, you have to research which libraries you need to do the work for you, right? The heavy lift for you, and you just add the specifics. In this case here, they just want to do some math. So there is a math library. There are actually two in here. Oh, sorry. There you go. There are actually two in here. One is a NumPy, and the other one is matplotlib. The matplotlib is just to show the information on the screen, right on the cell there, the bottom of the cell, the results of the cell, to plot the result in a particular way. So this library here, when import is to refer to a library. This is the actual name of the library. But sometimes these libraries, they either have very long names or names that are not that friendly. So you can define an alias, a nickname that only in your code within the Jupyter Notebook for this cell and any other cell that executed after this one here. In this case here, the nickname for the library is going to be NP. And the same thing for this one here, PLT, right? You see matplotlib.pyplot. So pyplot is another library, another element, another object that is in there inside the matplotlib, and they're bringing just that particular object. How do you know this? How do you get to figure these things out? That's when you go into the documentation of the libraries and start looking what you need to accomplish a job. This job here is just to plot a graphic. They want to plot a graphic, bar graphic, with the oxygen level inside the International Space Station. What they're doing here is actually generating a random number. So it's not real data, right? It's just to have fun. They generate a random number. So random is a member of the library. See the NumPy library. And the range is going to be around this one here, 1, 2, 3, 4, 5. It's going to be the range of the number they will be creating. And in here, you'll notice, right? This guy here, data, is the object. Every time you see a name and an equal sign after that name, it means whatever was before the equal sign is a variable. A variable is a memory place, right? An address in memory, a memory place where information will be kept. So this variable here is holding a collection of instructions to generate random numbers. So anytime from now on that I need to generate random numbers, I can just tell the object in this variable data that I need new numbers. And numbers can be of different types. There are types. And as we move along the learning path, you're going to see these types there. In this case here, it's using that object, data object, to generate random numbers, as I saw over here, to create new numbers and numbers of type integers. Numbers, you know, they can be like whole numbers, 1, 2, 3, 4, 5. They call it integers, or they can be decimal numbers like 1.5, 3.2. So these are decimal numbers. There are a couple kinds of decimal numbers. In this case, because just when it's simple, it's going to be a number between 1 and 10. See, 1 and 10. It's going to be between 1 and 10. So give me random numbers in between 1 and 10. And I want a sequence of 10 of those numbers. So this particular method in here, so integer is what we call a method because it belongs to an object and has, you know, this parenthesis in here, which means I'm sending information for the integer to work. These are called parameters. So we give you a lot of information. No, it's kind of a very heavy load thing here. A lot of information to take in at once. But again, you're gonna have your own time to go and exercise yourself on your environment, right? On these things, and they will get more information to you on that one. And okay, as we move along, let me see. Yeah, so this creates the array, and down here on the bar on the other library, actually, let me get it here on this other library here, CPLT. We get a method in there that's is the one that's gonna generate the elements, the code to plot a bar, right? To actually render a bar graphic, which with the numbers they were generated over here. So there is a range of number of elements, 10 elements in here, and the numbers that were in there inside the elements. And this one here shows the bar on the results of this cell. So when I run this guy here, let's get it. Oh, wow. Oh, sorry. I think I should. I'm missing something. Let's try that again. Run. Still. Oh, see, no module name NumPy. So one of the modules was not downloaded. So pip install. Oh, see, that one was not downloaded. It just downloaded it here for me, and it's installing the package. Okay, now the package is there. Let's go ahead and try it again. Now it's missing something else. I think I have skipped one of the steps there in the guide. But in any case, let's do pip install matplotlib. Downloading more packages. Those two libraries are not there. I thought they were, I mean, if you're following this when I recorded right from a YouTube channel and you're trying to do the same exercise there and it's failing, you know why, right? It's probably not there on the steps. So we just downloaded the packages in here based on what we have learned. Now the two packages are there for the library, and we're gonna try to execute this guy again. And now it works. There we go. So you see, it generated random numbers from 0 to 10, and 10 of them. And this is my array here. If I run this cell again, let's say I want to see 20 numbers. I run this cell again. Now I have a sequence of 20 numbers. See, random numbers. And if I want to change this from 10 to 100, just to have a wider range, then there we go, 100 over here instead of 10. And this is the seed for the random numbers. So if I want to see something different in there, I can try some other numbers in here and run this guy, and the graph looks different now, right? The bars look a little different. This is the seed for it. So what have we learned from here? We just had a review of loading libraries, right? That's so important. Otherwise, the environment doesn't know what to do. I don't know that thing. You gotta get in the libraries. Then you have to learn how to work with the libraries, right? Which method to call, what the method does. But for the language itself, we have learned that when we have a name with the equal sign, it means this name is a variable, and whatever comes out before the equal sign is the variable, like I said, and the name of the variable. And whatever comes after the sign is whatever value I'm putting that variable. If I keep going here into the learning path, yeah, the bar that was placed in there, that was nice. Here they have some more code, right? Let's do some shape calculations in here. So they're like, yeah, here's a markdown code. So let's get the markdown over there. Just for fun. What is it? Here. There we go. Markdown. Let's put the guy in there, shape code, and let's have an element for code in here. And my code on the next one is this guy. So let's see what this code does before we execute it. One of the things about development is when you must be able to predict what the code will do before you execute it, right? Because you're writing your code. At some point, you'll be creating code yourself. So, I want to accomplish a task. I need to have the instructions in there, and I must predict that the final results, the outcome of my instructions is what I really want. If you give instructions and it doesn't do what you want it to do, that's called bug. It's not behaving as it should. So in programming terms, we call that a bug. Okay, so this is a more simple code to look at. Look at this one here. No libraries are being loaded in here, which means we're using whatever is already on the environment, whatever is in Python and whatever is on the environment. And in here, we have, and in here, what this is. The name before the equal sign means it's a variable. Here I have 3 of them, which means this cell is creating 3 variables. The 3 variables are end velocity, start velocity, and acceleration. So I want to get to 60 speed, whatever speed it is. I start from 0, and we accelerate from 0 to 6 at 9.8 pace, right? Continuous pace. So the time to get from start to end is going to be based on this formula here, right? It's going to be a calculation based on this formula here. So what's the formula? It's the end velocity minus the start velocity. In this case, 60 minus 0, right? Because those are the values. Where's my thing? Those are the values, right, assigned to them, 6 and 0, divided by the constant acceleration over time, which is 9.8. So time to reach desired velocity is the result of this calculation. See, time holds it. Time is being shown here. Time will be shown on the as a result of this cell. So when I go here, and you see, I've been clicking here, but if you look close, let's see if it holds in there. No, it doesn't. If you look close in there, you can see on your environment, it says if you press Control, Alt, Enter, you can execute the cell from the keyboard. I always start doing that. Control, Alt, Enter, and execute the cell. So it says it's going to get in there in 6 times, whatever time it is, right? Seconds, hours, whatever time it is. It's going to get the 6 dot, whatever fractional in there. And you can see that the thing changes. Like if I want to get to 200, and I'm already running at 30 speed, whatever speed it is, the time to get in there will be 17.34 time, whatever time it is. So again, we have seen this before, variable assignment, we know that. And this is kind of new, right? We are doing math calculation here. So math rules, they kind of apply in Python the same way they apply in math. Whatever is in parentheses is calculated first. In math, you have parentheses and have the brackets and the curly braces. Here is just parentheses, one inside the other. Plus and minus are the same operators. The backslash here is the one for division. And if you go into the documentation, if you start searching these things, you're going to learn from the learning path. They will tell you that too. And print, just put it out here without graphics. See, just to put characters out, I don't need extra libraries. Python knows how to do that. But if it's graphics, then I need libraries. Back in here, keep moving. And that's it for this knowledge check. I mean, for this unit, right? So, you know, at the end of this units, they have this knowledge check, just like a teaser. So what file extension does the Jupyter Notebook have? Oh, that's easy. I just go back in here and look over here, right, on my file name. This is the extension for Jupyter Notebook. It was written on the course on the learning path anyways, but just to show that's easy stuff going on here. Which of the following answers include types of elements in an interactive notebook? Interactive notebook. So we have equations and UI elements, charts and graphics. We definitely have this guy here. We have this guy here. So probably both. And which of the following types of content blocks are available in Jupyter Notebook? Markdown, PDF, and HTML not supported. Yay, I got points. Yes, I love collecting points. Yes. Moving on. And so that's the end of the first element in here. If I click here on unlock achievement, I need to sign in to collect my points, right? So I'm not going to do that. I'm going to just browse here to the next topic. So I just finished this one here, the summary. The next one here is get started with Python in Visual Studio. I already showed you that, but just for you to understand that you all the ins and outs of installing the elements in Visual Studio will be reviewed here with you, so you get more details here on how to install the elements, how to install the Python elements on a Linux, on a Mac. See, they go over step by step with you, check the version of Python and all of that. So you guys can check that on your own later, on your environment. And here is where they really start the baby steps. So I made sure I run the complex one at the beginning because that's just the style of the courseware that Microsoft is giving to you. They start with something like kind of appealing visually, buttons, things are moving, there are colors, there are icons, there are math involved, so it sounds great. And from down here, from this third module here, actually, right, this is the third one, is when the very basics of the language will start. So, junior programmer, okay, I was in the International Space Station just a moment ago, now I'm a junior programmer. All right, we go with it. work with output, and then they come here with one more code for my cell. So I can either start with a new cell or start a new notebook in code, whatever I want to do. In this case here, I'm just going to add a new code, paste that code in here, and off we go. See, program fine. This is just a comment in the code itself. So with the pound sign here, it's just like, don't worry about this line, don't process it. Your structure is on the next line. So again, a name before the equal sign is a variable. Whatever comes after the equal sign is the value that will be assigned to the variable. In this case, is the result of this expression, 1 plus 2, very complex one, which means I will see 3 here at the end with the print. So you see, they downsize the whole thing. I was super excited. International Space Station. Oh, they downside it here. So we start with the baby steps. And if I go back here to the modules, you'll see that they start with this and they show you how to do the, actually they run this thing from the command line, which is kind of interesting. And then they go into explaining variables, which I kind of ran with you already. They go into the data types. Remember, have integers, whole numbers, or decimal numbers. They have strings, characters. These are all the types the major types you can have. Numeric types, text types, Boolean types. Booleans like true or false. It's the only thing you can have on the Boolean variables. And then they keep going here. So after this, I think you are on a good track to get started with Python. You have a running environment. You have your notebooks in there. You know how to place the code in a cell. And you have the basics about importing libraries when there is a missing library, how to bring the library from the open source repository into your own programming environment, and then start learning the code. From here on, I'll let you with the courseware, so you can keep learning on your own pace in there. And I'm just gonna check out here the last questions, if there are any. That prints it, but the button text does not change. Oh, I see. I'm sorry. I think I misunderstood your question there, right, Doug? Let me go back there and just quick. Here. Let's get a code in here for that button. Let's go back here on the button. So where is the button? The button is on my ignition object, right? That's been working with the thing. And there is a property in the ignition object, clicking, saying start engine, right? This is one here. So you want it from start to stop. There's one thing here that I did not mention. It's super important in Python. It's very kind of specific to Python. There are some environments that are like that nowadays, but in Python, it's super important. Space. See these spaces in here? They're not just to make Python look good. They are mandatory. They say that this instruction setting here belongs to this line. And this line here, this keyword def, says you are defining a function. The function name is onChange value. And this is the code that belongs to the onChange value. So space, if you put one extra space in there, it breaks the whole thing. And if you break the lines in there, it messes up the whole thing. So it's spacing in Python is I cannot believe that I almost forgot to mention. Spacing in Python is king, right? It's super important. And another thing to keep in mind is this semicolons. Oops, something just popped up here on my screen. There we go. Is this colons here that show up? They also say that the code that comes after it belongs to a multi-line structure, right? So it's important. It's a definition of a multi-line instruction. It's important to have in there. So in this case here, if output new print engine started, and I also want to have ignition dot description change to stop And uh, here, get back to start engine. So let's run this again. Let's see if that goes. There we go. Stop, start. Was that done? What are you asking about? Right? Notice that the ignition description, right, is an attribute of, sorry, here. Description is an attribute of the button, and ignition is the object of the type button. So there is an attribute called description into ignition. So just changing the description attribute of ignition to whatever I want makes the button to re-render itself as you asked. I hope you're still there, and I hope that addresses your question. So with that, I will give it back to Faraz for any more questions, if there are any more pending questions there. Otherwise, this is it for our session today. I hope you have learned something new for us.
Thank you so much, Armando. We appreciate it. Everyone else, again, I'd like to thank everyone for joining. And please, if you have some time, I dropped in the AKA link for our reactor survey. Please use the code 15890 to fill up the survey and let us know how this event went. And other than that, thanks again. And thank you so much, Armando.
My pleasure.